Welcome back for our next panel discussion, which will be considering how complementary technologies can support gigabit broadband rollouts, taking a particular look at strategies for delivering FTTep, fibre to the most economical point. Craig Thomas, Vice President of Strategic Marketing and Business Development for the Broadband Forum, will be chairing the panel. Don't forget that if you have any questions for the panel, you can submit them via the live discussion box and the speakers will try to answer them during the discussion. And now, without any further ado, let me hand over to Craig to introduce the panelists.
Thanks very much and welcome everybody. As just previously said, we are really going to be focusing on today about what are our options in regards to delivering a gigabit service when the fiber all the way to the end user, that last drop, isn't necessarily logistically or economically possible. And we're going to look at all of those options that are available, as well as some new open standards work that have been introduced to the industry just this year. Joining me today, I'm lucky to have, first of all, Helge Tiernen, who's Head of Product Management and Marketing and Sales at InCoax Networks. He's also very renowned inside the industry for a lot of the standards works he does in many organizations across the industry. Also joining me is Mike Talbot, quite a renowned figure in regards to his position as Associate Fellow for Device Technology at Verizon. And similar to Helge, he's very active in the standards work in the industry, especially as a Vice President and Board Member at MoCA. And then finally, in starting off our session today, we're lucky to have Simon Fisher from BT, who's a Principal Architect of Access, and therefore in a great position to talk about some of the challenges that he faces, as well as the industry in regards of trying to deliver a gigabit experience all the way to the end user. So on that note, I think I'll pass over to you, Simon.
Okay, thank you for that, Craig. Thank you for that introduction. If we could have the next slide, please. Thank you. Yes, I'm Simon Fisher, and I now work in BT Technology as the architect for the access network. A little bit of my background, I've spent the last 30 plus years, it must be now, specializing in access networks, both fiber, DSL, radio, and some other technologies. But I suppose the focus I'll bring on the discussion today is to represent what are the operators' challenges in rolling out a network where customer expectations are growing. They don't assume that being just one of three houses 50, 60 kilometers away from the exchange in a rural area would be a problem. And some of the other combinations of technologies that we use to overcome what are a real challenging set of scenarios when you're looking to deploy mass fiber rollout across a country, or in my case, the UK. If I could have the next slide, please. I've got two slides that I'd like to focus on. This first one basically shows how we use complementary technologies to overcome a lot of those reach challenges and bandwidth challenges. And the second slide is going to look at the real tricky bits. Okay, what are the scenarios that still leave us with some real problems in terms of challenges we need to overcome? But just to set the scene, this slide from top to bottom looks at what we have today in the BT network in the UK, which primarily is fiber to the cabinet, which is covers a very large percentage, 90+% of all customers in the UK can be served via fiber to the cabinet. From the exchange on the right-hand side, the exchange building, housing the line cards and the layer 2 switch, all the way through to those customers on the far right. And on the right side, there's two things I'd like to emphasize, in that there's a huge range of customers we're serving, from residential through small, medium, large business, and possibly even mobile and small site towers and antennas as well. But those customers sit in a wildly different range of geotypes, from town centers, city centers, where service provision is very dense, to rural environments where even if the reach isn't a challenge, the fact that you've got to get service to a few handfuls of customers, the economics of that are challenging. So moving from FTTC, which we use predominantly today in the UK, we're now, as well publicised in the press, rolling out mass rollout of all fibre to the premises, typically on a GPON technology currently, but with clearly eyes on what we're going to do next in terms of PON evolution, going to XGS-PON. And that GPON technology is typically over a 32-way split and can get us out about 30 kilometers quite easily before we need to worry about optical reach and making sure the optical power budget of what we put in today is also suitable for what we intend to roll out tomorrow and beyond. And we've got point-to-point services for carrier class and resilient service delivery to mostly large and large businesses. Customer expectations these days, well, we've gone from the few tens of megabits that FTTC delivered now to customers assuming that an operator's portfolio is going to allow them products up to a gig for a residential customer. And for businesses, enterprises, typically you start at 1 gig, and we've got a growing demand for 10 gig as well. In the case of the mobile space, may even be 25 gig. Some of the initial challenges we face as we get out to the sort of niche areas are extended reach. The first thing that challenges is 30 kilometers just isn't good enough. So in the Armory, we can either drop to a 16/8 or 4-way split, which I think the technical limit of GPON is somewhere around the 50-54 kilometer reach before we start having transmission problems. But if we need to go beyond that, and frequently we do in rural areas, we look to sub-tend the OLT head end, GPON head end in this case, into a street cabinet, powered street cabinet, and feed that off a point-to-point link from the local exchange. So that can give us a boost of somewhere between 40 and 80 kilometers on that point-to-point backhaul, and then leave us with, again, 30 kilometers out from that cabinet to cover the customers in the catchment, which is a pretty good tool in the Armory to have for extended reach. Physical barriers, getting across valleys, over rivers, lakes, and sea. In some cases, we also use radio technologies point-to-point, which enables a few kilometers up to about 10 kilometers with a sort of 1 gig sort of backhaul solution there, and then subtending head ends off the end of that. The real tricky areas that we need to focus on in this discussion are sort of down the bottom here. We start to lift the lid on what's the real problem. Well, start with rural areas. Digging fiber all the way into a customer's front room or living room is expensive, obviously. So we are continuously looking at innovative ways and alternative technologies to get that service into that customer at a performance level that we expect. And one of the areas we're looking at is fixed wireless access. That can provide us with a small tower in a cluster of houses with a few hundred megabits or even 1 gig up to a few hundred meters of range around that tower just by putting an external aerial on the customer's premise. So that's one possible way for avoiding the complex time and cost of trenching fiber all the way into the customer's front room. The other one is the challenging situations, MDUs. Now, in the past, we've looked at MDUs, multi-tenancy dwelling blocks and office blocks with some interest, and we are still continually challenged by the scenarios. In the UK, the MDU scenario is a bit different from probably Europe and the US. They're not big tower blocks. They're not big, shiny office blocks. 80% of the MDUs in the UK are 14 apartments or less. And so the economics of what the solution we're trying to put in there is very challenging. And something we've tried in the past and to this point walked away from is like putting fiber to the basement and then using a GFAST technology across the existing internal twisted copper pair infrastructure of that MDU. Not because technically it didn't work, because it definitely would work. It was just the sheer complexity of the OSS needed to manage either a PON or a point-to-point solution, feeding an active piece of electronics and then GFAST over cabling, which we may not indeed own. We may have to adopt it. And the sheer complexity of service provision and in-life T&D on that type of architecture. So that has proved us a problem in the past, both economically, but mainly due to the volume of sites where we'd actually need it, which is quite small. If I could have my second slide. This really focuses in on, okay, well, where are the particularly challenging areas? And there's 3 I've got focused on here. The top one is where we go into an industrial estate or a campus, university campus, for example, or a hospital site where there is a lot of already existing wiring, typically twisted pair, which may not be ours. It may be ours, it may not be ours. There may be Cat5 in there as well. And it's really a bespoke survey to work out what we could do in that sort of scenario. MDUs, similarly, as I've already touched on, the internal cabling is often a problem because it's not ours. It may be coax, it may be twisted pair, but the sheer complexity and cost of overbuilding that infrastructure with all fiber, even though we have some very sexy low profile fiber solutions which are economic to plan and deploy, is a challenge. And then finally, non-ducted sites, where in the 1950s and 60s, one of the practices was to direct bury copper cable to feed housing estates. There is no duct. So if we need to put fiber in there, we've got to break ground again and trench it, and that's expensive. So I don't want to say too much more because I'm just teeing up the discussion really, but on the left-hand side, you can see the real problems that an operator doesn't want. If you're mass rolling out fiber at speed, you want to do cookie cutter type deployment. You don't want to pause to try and find out who a building or a site owner is and agree a solution, do a complex and time-consuming plan, build and survey of that. And lastly, just to say, I think we all need to be conscious there are other technologies coming. There's a lot of talk in the technology, in the industry these days of 4 and 5G in-building solutions, which will eliminate the need for in-building cabling at all. And obviously all IP solutions typically eliminate customers' needs for analog telephony over twisted pair copper cables, and they're moving towards more advanced solutions. But I think I'll leave it there because I think that tease up the scenarios from an operator's point of view, and I'll hand over. Thank you.
Yeah, thank you, Simon. That was excellent. I appreciate that. So without any more interruptions, I'd just like to hand over to Mike, who's going to give us a little bit more of an introduction to fiber to the extension point, as well as some viewpoints from the MoCA side of things. So Mike, the floor is yours.
Yeah, hey, thanks so much, Craig and Simon. Fantastic presentation. My name is Mike Talbert. I'm an associate fellow with Device Technology, really focusing in on premise architecture. I was with Verizon when we launched fiber to the home back in 2003. Carrie, if you could move the next slide, please. Again, it's just a safe harbor statement. Some of the comments made today may or may not reflect what Verizon specifically is doing. Next slide, please. So when we look at our existing fiber to the home connectivity, the architecture is pretty simple. You know, Verizon moved forward by deploying VPON over from their central offices directly to the home. We've moved forward with a GPON implementation, and as we look forward, there's some exciting things moving through to GPON. You know, obviously, as we get this extended bandwidth to the home, obviously it's going to be very important to allow the consumer to be able to support that level of bandwidth across the home. So we have a number of technologies moving forward in that area. You know, obviously Ethernet's still there. MoCA Home is a technology, you know, 2.5 gigabits per second, offering a substantially decent backbone throughout the home, supporting Wi-Fi distribution, as well as the upcoming 6 gigahertz Wi-Fi spectrum in the US, offering 1.2 gigabits of, gigahertz of bandwidth to really take that gigabit and multi-gigabit technology across the home. But as Simon alluded to, there's times when, you know, getting to the home is a challenge, and more importantly, as we look at multiple dwelling units, it's not always easy and simple to bring fiber to the premise. So what do we do moving forward? Next. The Broadband Forum has been very proactive in this area, authoring TR 419, Fiber to the Extension Point, where we can look at the existing connectivity from the central office through the optical line termination, or OLT, through our optical distribution network. When we then look at the optical network unit, or ONT, allowing for a conversion from optical to electrical, where we could then place a network head-end unit for allowing conditional access. That conditional access could then be distributed through a copper distribution network using existing facilities, i.e. coax, i.e. twisted pair, to allow for the distribution into the premise, specifically or probably primarily effective in multiple dwelling units or larger buildings that have existing structure. That is then interfaced with the network termination equipment into the home distribution network. TR 419 was authored by the Broadband Forum. It's out there really defining how do we get from fiber to the endpoint and then extend it out effectively and economically into the customer premise. And so as we move into the next slide, that's where it's been pretty exciting with the MoCA Alliance. MoCA has announced MoCA Access a number of years ago. As that technology progressed with MoCA 2.5, we now have MoCA 2.5, allowing for that fiber extension technology to really transverse into the in-building coaxial cabling. It is based on the MoCA 2.5 specification, allowing a 2.5 gig downstream by 2 gig upstream. It's extremely low latency, less than 5 milliseconds, and allows for point to multi-point connections supporting up to 63 clients, obviously oversubscribed. The important point about this solution is it does leverage existing building coax, which means that in most of the US multiple dwelling units, they're able to leverage the coaxial that's been used primarily for QAM or TV delivery as an option to deliver IP over that solution. The MoCA Access technology has been embellished by a number of companies, and I'm proud to announce that InCoax is one of those primary solutions that we support from the Alliance perspective. That said, there are a number of other solutions to allow for extension of copper. Obviously G.hn supports some of that. When we step back a little bit, there is, to Simon's benefit, a lot of work going on around 4G and 5G. I'd be remiss in saying if that is not another way to tackle some of this. However, when we look at multi-gigabit access, obviously running over a wired medium will give us that deterministic behavior and quality of experience that our subscribers are looking for. That said, Craig, I'm going to turn it back to you, and let's look and see what Helga has to offer.
Absolutely. Thank you, Mike. And yes, let's pass over to Helga and InCoax, who obviously, with their sponsorship, have enabled this session to happen. So Helga, maybe you can go into some more depth in regards to what FTTep is all about.
I will indeed do that. Can we take the first slide, please? I'm working for InCoax Networks. We have been in this access technology area reusing existing infrastructure for around 10 years. And I have a long telecom background from both larger and smaller companies like Nokia and Cloudrister. So I'm a techno guy, but also marketing and sales. And that's the reason I probably have a little bit too many hats today, covering 3 areas in our company, but it's my long background. I'm active in the MoCA Alliance and sharing the MoCA Access work group. And I was also co-editor to TR 419, the fiber access extension technology, the FTTep, and also contributor. And with that, it has come also that I have become the editor of the SCTS 101-548, which is RPF over coax networks. And also now continuing on that area, I will work with as editor of the RPF testing of a coax network. So it's very much about how can we reuse the existing infrastructure. And of course, I've been focusing mainly on the coax side because it can provide higher frequency ranges than the twisted pair. Next, please. And of course, one of the biggest challenges we have, and we meet this every day, both in Europe and US, is that if you are going to wire new cabling into an MDU, there is a number of steps you have to go. There's a number of hurdles if you're going to get those in place, especially if it's a condo, you have to get everyone's approval. And wiring is not easy because there are no ducts, and you have to put ducts outside on the walls, and people don't like that. So if you can use or reuse the existing infrastructure, then you reduce the number of steps before delivery to in principle 2 main steps. and then you can start the service delivery. So there is a big advantage of using the existing infrastructure. And if you take the next one, the same thing is with the multi-tenant units. You don't have, in this case, the condominium. Condominium means that you have to have a consensus agreement that you get wiring, but in this case, it is a building owner. So it's a little bit easier, but still there is a number of steps you have to take. And one of the issues we hear very often is that should the building owner decide which services the tenants will get? And that lands in the discussion of open networks and open services, which also complicate the whole thing. So if you can reuse existing infrastructure, that will simplify the service, and you can even coexist with DOCSIS services and also if you have DSL type of services. So it makes the life much more easier, and we see this in the daily work. We are today already delivering these type of FTTep solutions both in US and America, and when people start to realize the benefit of that, you can use an existing infrastructure. That's a big advantage, and it speed up your deployment. If you take the next one, and of course there is a big economical advantage of using, which is there already. I mean, a coax network can provide in principle the same speeds as a fiber can do. In the MoCA Alliance, we have the 2.5 gig solution, and we are also looking on the 10 gig. So if you follow the service speed which you do over fiber. But one benefit is that if you're going to deploy fiber to a small MDU, mid-size MDU, or large MDU, and you still have a rather low take-up rate, it's a very costly investment, because you typically maybe get 10 to 30% in the beginning taking up, but still the cost of deploying this is increasing with the size of the building, even if you get more subscribers. And this is for gigabit services. And MoCA can provide symmetrical gigabit services when it is a point-to-multipoint solution. If you take the next one slide, which is a multi-gigabit services, as was mentioned by Mike, that MoCA can provide 2.5 gig, and that's the next step. We see this already happening now in US, that operators start to provide multi-gigabit, which is principally 2.5 gig. And of course, that investment will be more expensive because the equipment is more expensive. It's 10 gigabit XGS-PON on the fiber side, and then you have individual connections to each of the subscribers. It increased the cost, but still the benefit of using the existing infrastructure, which is point-to-point in this case, is much more better than investing in a new fiber infrastructure. If you take the next one. And then we come to what is fiber to the extension point. This was very much discussed in the standardization work. And what is the difference between FTTBP and FTTep? We will touch down on this question later, but the reason why we took this was that when we get new access technologies like coax, the entry points are not anymore the same as you have in a twisted pair case. It can be an outdoor cabinet. In this case, it can also be in the building. It can be on the loft, or it can even be on each of the floors. So we had to take that in consideration. And it is describing the model where you can install your so-called DPU, a distribution point unit. And if you take the next one, please. And of course, what is a device which is doing fiber access extension? It is, in this case, it is MoCA access. Of course, you could use G.hn, but it has an optical network unit. It has a MoCA interface, and in this case, it's a point-to-multipoint. That means you divide the signal to up to, let's say, 30 subscribers. And of course, you cannot get, if you have a 2.5 gig MoCA link, you can't get, 2.5 gig to each of the subscribers. But in this type of solutions, you can provide up to 1 gig symmetrical services if you don't have too many clients behind that. And it's a question of what is the service you want to provide. And of course, the idea with FTTep is that you use the existing protocols which you have already there to manage this. It's NetConf-Young, TR69, SNMP, Ethernet OIM. So it's leveraging a lot of the existing infrastructure you have already on the management side. So this is only extending the fiber over a copper medium, and copper medium in this case is coax. And if you look on the point-to-point, which is the next slide, the difference is that you have an individual connection, and this individual connection can provide multi-gigabit services. And we are already today starting to deploy these type of solutions where you have a point-to-point connection, which means that you can offer not only 1 gigabit symmetrical, you can offer two gigabit symmetrical services. And of course, compete with the cable operators, which are also starting to address these services. So if you look on a deployment case, for example, in US, there is very much of the coax network are point-to-point. Which means that in a building, an MDU building, there comes a fiber operator and he connects in an MoCA access DPU. Then he starts to sell his services. And then when he gets a new customer, probably he take that from a cable operator and connect, and then that operator get a new subscriber without have any cable installations. And the MoCA coax network termination unit is self-installed by the customer, and it can also be integrated in the residential gateway. So it's a very easy way of deploying, because if you have a point-to-point connection, there is only a wire going up to each of the subscribers, and MoCA is very robust. So even if you have a little bit loose connections, you can send the services, and you can select and coexist with other TV services if you want to do that. I think that was my last slide. Thank you.
Brilliant. Thank you, Helge. Greatly appreciate that. And it brings us nicely, I think, into a little round table Q&A session that we can really try to highlight some of the and clarify some of the points that you guys have made. So I appreciate that. And just looking at this, I'm going to kick it off with this one. So from a fiber to the extension point, are we just talking about utilizing within the existing brownfield area, the in-building infrastructure that already exists, so that legacy infrastructure? And if that's the case, and I think this is a point that Simon brought up as well, who owns? Does it make it difficult where there's no one strict rule of who owns that infrastructure inside the building? Who'd like to answer that one?
I can maybe start, because we have done a lot of investigations both in Europe and in US, and partly also in China. In Europe, now we speak about EU. I don't know how laws will change in UK after the Brexit. But in Europe, the general rule is that the building owner is owning the infrastructure of the building. It's the same with water pipes, with electricity, and also the coax network is owned by. And for telephone wiring, it has been a little bit different, but I know. But it is very much depending on, and in EU we have also had deregulation on this part. I have been part in that discussions in the European work that cable operators should not restrict a competitor to use the infrastructure. And there is rules around that. And if you can't agree with the cable operator, if they claim that they have an exclusive usage right, which is the typical case, and this was maybe made when they built these star networks many years ago, these have typically gone out because they cannot anymore defend. So in many cases, the coax networks are available. And in US, it is 90% point-to-point. For example, Germany is 50% point-to-point. But then we have also the satellite networks, which is, for example, in UK, and these are also point-to-point. So there is an opportunity which very few knows about, and it requires a new competence, which is not a twisted pair. It is the coax network. So people who have been working with that are valuable and tell what structure is available. But we have been investigating this. So typically the ownership is building owner, but there can be exclusive usage rights. But then you can go to your like Ofcom and get the discussion around this. So it's not the barrier of using that.
Mhm.
No, if I could just follow up on that. No, I don't think it's a barrier at all. I think I think that the problem is, and because the problem is so challenging, I mean, BT and OpenReach with its open access model has floundered on MDUs for many years in terms of we dismiss certain ideas because, oh no, that's too complex and too costly. And in terms of a service wrap or a management system to actually management, you know, it's just far too complex. And then there's a 2-year gap while everybody realizes, well, what are we going to do then? And then you suddenly realize that it may actually be worth the challenge. Now, because as I alluded to in my presentation, we certainly never close the door on any technology and never say never, because yeah, if there's an asset there, be that owned by the operator or owned by a third party, and you can adopt it, it does make sense to try and use it. It's just it's just from where are you starting from in terms of how keen are you to solve that problem and how much resource and money are you prepared to put in to solve it? Because technically we can certainly do it. It's the service wrap, and when the customer rings up and says my service has gone down, how do you prove a fault on or off your part of the network? Who do you call to fix the bit that is wrong? Who do you dispatch where with what to solve it? And they're the more complex questions, but they're certainly not showstoppers. They're just people keep wandering up to these problems and thinking, oh, this is a bit tricky, and wandering away again. And we've got to get a teeth into it ready to solve it.
Great. Mike?
Yeah, so in the US, it's a little bit different story. You know, primarily the coaxial network that sits inside these multiple dwelling units is primarily owned by the cable provider that had an opportunity to get in with the building owner at the inception. You know, kind of sealing up that contract with the building. That does present some challenges. However, the opportunity for extension is significant when you look at some of the smaller buildings, some that Simon alluded to, these 14, 18, 20 type of apartment buildings. Lots of opportunity there where the actual infrastructure is owned by the building owner itself. So it allows for an opportunity of competition. You know, obviously one of the big advantages to MoCA access is it sits on top of the spectrum, meaning it can coexist with TV services that are provided by an incumbent MSO. So it gives us an opportunity to really jump into those type of opportunities.
A great point. And I guess, you know, one of the barriers is, irrespective of who owns the fiber, you still need to get access to the building, you know, and the landlord has to see the benefit of gigabit services to give you access and want to give you access to the building as well.
I can see the deployments which we are doing now in the FTTep in US. The situation is that there typically are a cable operator, and there is a TV amplifier, and the demarcation point is typically after that TV amplifier. And then there is a splitter. If there is 8 apartments in the building, you have an 8-way splitter. And but we have a number of fiber operators who go in and sell the services. They install the DPU box, get the fiber to the building, and then they make agreement with of course with the landlord, but they can be there because you have to have power and so on. And then when they get a subscriber, then they disconnect the subscriber from the existing TV service to their service. And then there will be no coexistence. It's only gigabit services they start to sell. So it's a trend. It's not big yet, but we see it's growing very rapidly, at least in the main city areas. And I mean the reason for why they're doing this, they have at least one of these operators have very good knowledge of the coax and know the structures and know all the legal aspects. So it's not possible, but it requires a certain amount of work to understand the situation on your specific market, and I can guess the markets are different even in the country.
No, absolutely. So let's double down here. So we've been talking about fiber to the distribution point, which maybe predominantly was GFAST related. What's the difference between fiber to the distribution point and what we're now talking about here, which is to the extension point. Is there any major benefits or differences that we're talking about?
Maybe I
Go on, Simon.
Okay.
Well, I was
Okay,
looking at Helga
first.
to take that one.
Well,
Go on,
as
Simon.
a co-editor of the standard, I think, Helga, you should go first.
Okay, I mean, we had a long discussion around this because fiber to the distribution point was very related to GFast, and it came that it's the outdoor cabinet where you install your DPU, and then you have typically, if you don't have power there, you have a reverse powering, and that came very synonymous with GFast. And when we started to investigate the other technologies which are available, like D.HN and Mokka, maybe we will get other installation points which are not the cabinet out there. Then, of course, these we couldn't call them DP because that was very much focused on where the telephone lines maybe 200-300 meters from the building started. So we have to create a new name, which was FTTep, because it's an extension point. It can be each on the floor level, for example. In a large MDU, you maybe have your DPU on the floor level. And in countries like Italy, where you don't have any cable TV, you have typically antennas on the roof, then it can be on the loft. So we had to create a new name. And then some of the group members said it's the economical point, not the extension point.
So one of the interesting points, I think, and Simon, maybe you've got something to say here, was from the management perspective and how the network sees this new extension point compared to a DP.
Yes, I mean, certainly the last time we seriously investigated using, as Helga commented, was GFast technology, we were looking to put into the apartment or just outside the apartment, because one of the other fallacies in the UK is we say fiber to the basement. Typically there is no basement and there's no power, so that's the first problem. But there's no issue in putting electronics like this just outside of the building. I don't see that as a major challenge. Cabinet technologies with all the life support systems clearly add a bit of cost, but it's not that much these days. But yeah, one of the problems we had was because of the size of our MDUs, the economics meant that we were trying to feed that GFast unit with a PON. Now, when we started to look at our OSS, operational support systems, when we started to pull that apart and try to work out how do you provision a service, how do you guarantee a certain level of service performance, how do you T&D that, test and diagnose that when it goes wrong, trying to do that across a PON domain. The OSS would the only way it could handle it was as a PON domain and a DSL domain. When you try to put those two together, it did become, even from a capacity of bandwidth realization, it became very difficult to get your head around, certainly very difficult to engineer a service over. So then we started to look at point-to-point, because that's no different from fiber to the cabinet, really. They're all point-to-point. But when you start to look at point-to-point electronics and transmission combined with GFast, the cost point was just nowhere near what it needed to be. And at that time, it was complicated by the fact we needed battery backup as well to maintain lifeline service when the power went down. And some of those problems are going away these days because we've moved on a bit. But yeah, when you sort of lumped it all together, no basement, no power, no space, two different OSSs, it just became a bridge too far. But so we chose at that time not to go down that route. But as I say, we've still got the challenge. We haven't solved it. So we may choose to go back. And as Helga said in his presentation, they have recognized that and they have made moves to make that management of that end-to-end across different domains easier. So yeah, keen to understand that.
Yeah, I mean, we did the latest platform, which we now are in the launching phase, that was built on exactly this problem, because it started really in Italy, because the building size were okay. It went even back to I think it was in Switzerland. We did a big work with the tier 1 operator there, and the building size was in average 8 apartments. And when you went to Italy, they were even smaller. So we started to look, how can we make an PON extension, because you want to see this as a PON element. You want to use your OMCI protocols to handle the opticals. You want to use a NetConf modeling, which you recognize in your existing system. And then we landed in a new platform, which is in principle for small MDUs. And it's like a virtual bridge for your PON extension. You can use your existing management tools in the OSS with NetConf modeling and all these, modern tools which are available. So we have seen that problem very much among many operators, especially the most difficult case is the small MDUs, because you get a low take-up rate, you can't invest too much. Even the fiber investment maybe is too high, but maybe you can ratify that because you have maybe 8 subscribers sharing that. Of these, maybe you get half, so that can ratify that. But you cannot ratify the in-building cost of the fiber, which can be up to 40% of the cost to the building. So this was one of the goals with the FTT, with the TR419 and FTTep that make very cost-efficient EPUs, which can be reverse powered from the apartment, because these probably sit outdoor of the building, and they have to be even. We have customers in Texas. I mean, it's very hot. They have to be able to be in a very hot climate and very cold climate. So that challenge we have been working on a couple of years now to really find a solution. And we recognize this for many operators that the small customers are really the difficult, and we have tried to address that.
Thank you, Helge. Yeah, no, great point. Mike, you may have just 10 seconds to answer this one, but a question from the audience is to expand on the fiber gigabit services. To what extent do you utilize node splits? You're on mute, Mike, I'm afraid.
Yep, sorry about that, Craig. So we're commonly at a 1x32, which allows that gigabit plus access. As we move into 10 gigabit PON or NG-PON 2, up to 40 gigabit, we'll look at 1x64, probably more commonly than not. We have a significant amount of outside network in place. Today, really probably split between 1x32 and 1x64.
Great. Thanks, everyone. Great session. Really appreciate your support. Thank you all and take care. Thanks for listening.